Hi everyone, we're just checking out the mic right now, just making sure that everything is working.
Yes. Everything good?
Everybody hear us? Everyone see us? Everything good? Good.
Let us know in chat.
Yes, please.
Hi everyone, and welcome to this online user group. My name is Sam, and I'm an online evangelist at Unity.
I'm Liz. I'm a technical evangelist here at the Brighton office in the UK.
And I'm Kieran. I'm also an evangelist, an art evangelist. This is my first online user group because I'm quite new to the team.
Welcome!
Welcome!
And I believe it's my mission to show Unity from an artist's perspective.
Hey, that's a good mission.
Thank you, I know.
We've got a lot of exciting things lined up tonight, haven't we?
Right. We have, first and foremost, we're going to take a look at the brand new SpriteShape feature, which is super interesting. And we also have a game called Houdini, which you might have heard of if you watched the Unite keynote, right? Because they talked briefly about the game.
Mm-hmm.
Harold Halibut.
Harold Halibut. Sorry about that. Good thing you corrected me. My bad. And we also have the HDRP feature in Unity.
I'm very excited. Very, very excited about this.
Yeah, Kieran is our resident HDRP, which is high definition render pipeline, for any of you who don't know. But we'll be referring to it as HDRP, you know, inside lingo.
Right.
Yes.
So you're our resident expert here, right?
Yes, I am. I've kind of I've made it my mission to learn HDRP or high definition render pipeline. So, yeah, we're going to chat about that later.
I like your missions.
Awesome.
Thank you.
And before we get into it, I just want to turn to you because you had a busy month so far, right?
Yeah, I literally have just got back to Brighton.
Boy. Welcome back.
Thank you. Yeah, so it's been a super busy month for Unity. It's been great. It's been really exciting.
Yeah.
So we started the month off at SIGGRAPH, which, if you've not heard of SIGGRAPH before, is a graphics-focused conference, which was in Vancouver this year. So we were there with the Made with Unity team, the evangelists were there showcasing, and we had some cool automotive demos too. But we also had a really cool announcement.
We did. So Unity partners up with Disney to create a series of short films rendered in Unity called Baymax Dreams, starring the one and only Baymax the robot from Big Hero 6.
Special
So,
guest.
I know, he's just sat here. So if any of you want to find out more about this, we actually have a behind-the-scenes video about the whole process and the whole development team. So we'll put that in the chat, and for any of you that want to have a look, you can do so.
There was a blog post that literally landed like 10 minutes ago as well.
Yeah.
Perfect
timing.
Yeah, and it's just super cool to have been at SIGGRAPH and to hear about Baymax Dreams.
Yeah.
Because it's just such a great application of Unity outside the gaming world, if you like. It's really exciting to see see the developers using Unity in these super new ways. And there'll be lots more of Unity for film-based stuff at Unite LA. So stay tuned for that.
Yeah. And not only SIGGRAPH, which I'm already jealous because you got to attend
great.
there. I really want to go
So
to.
much fun.
But also Gamescom, right?
Yeah, I love Gamescom. Gamescom's probably my favourite.
I don't know, Gamescom is one of those events where us evangelists actually get to see the people behind the names on social media.
Yeah.
You know, it's one of those things where we can see the developers that are using Unity, talk to them face to face, and just see what they're working on. It's one of those events that I always look forward to. I don't know about you two, but yeah, it's an amazing event, especially for us evangelists. So yeah.
And we had a lot of great developers on our booth as well in the business area. So we had GTFO playable, which was super cool.
Right.
We had CodeSync there with They Suspect Nothing.
Yeah.
And also Harold Halibut, which we'll be hearing a bit more about later. Which is a good point, actually, because if you're like, I didn't get to go to Gamescom, I'm super sad.
Yeah.
Well, we have Harold Halibut's interview later, and we also have, which is coming up now, a talk on the 2D SpriteShape, which was actually one of the technical talks on the booth that we had. So don't worry, you didn't miss out. Should we get started with that, do you think?
Yes,
Yeah,
I'm
sure.
looking forward to it. So
2D SpriteShape, here you go.
Yay.
Hello, my name is Alice, and I would like to welcome you to this demo on 2D world building with SpriteShape. If you haven't heard of it before, SpriteShape is one of Unity's preview features which makes it easy to create complex and organic 2D environments. It works by tiling sprites along spline paths defined by the user. If you've ever used tile maps before, you'll find that SpriteShape is aimed towards a similar goal. However, where tile maps are better for more rigid and pixel-perfect environments, SpriteShape allows you to create almost any kind of shape. If you've ever used Photoshop, you'll find that SpriteShape works similarly to the Path tool. And if you haven't, that's no issue. I'll demonstrate it in the editor and it will become crystal clear. So why use SpriteShape? First of all, it's very visual. There is absolutely no requirement to be able to write any code to get started with SpriteShape. But of course, it can be enhanced with code too. An example of this has been shown at Unite Berlin, where a script was used to attach an object to a node on the spline. As you can see, when the spline moves, so does the object. Finally, it allows your artists to spend less time on creating iterations of the same assets and focus on more important work. In this demo, I'll make sure to get you well acquainted with the general SpriteShape workflow, so that when you leave, you can start confidently creating your own environments. I will also show you how you can prepare your sprites for use with SpriteShape by using the Sprite Editor, another of the newer Unity features. I will show you how you can easily generate colliders for your shapes with 2 clicks. And finally, I'll give you a short demonstration of what can be achieved with scripting. So without further ado, let's get into Unity. What I've got here is an empty scene and some assets that I've pre-imported into this project. The assets I will be using for this demo are from the 2D game kit, and you can get them yourself from the asset store. Before I move on, let me show you how you can get SpriteShape for your project. Like all preview packages, you can get SpriteShape using the Package Manager. Go into Window, Package Manager. In the All tab, you will be able to find SpriteShape and other 2D packages here. I've already got SpriteShape in my project, but if you didn't, you would have the installation button right here where it says Remove for me. First, let me tell you a little bit more about how SpriteShape works. It consists of 2 main components, one of which is an asset and the other is a game object. The asset, which is called the SpriteShape profile, is used to define and store information about a particular type of shape, instances of which you will create in your scene. The game object is an instance of that profile in which you control how your shape looks and behaves. So, let's begin with creating a SpriteShape profile. If you right-click in the Assets window, go to Create, SpriteShape Profile, you will see 3 options. The only difference between these is the predefined angle ranges that they come with. I'll explain angle ranges in more detail in a second, but let's just start by creating a strip profile. We can now edit our profile in the Inspector window to the right. As you can see, the strip profile comes with 1 predefined angle range, which covers how the sprite is displayed from all angles. Each angle range determines which sprites are rendered when your curve is facing that particular direction. A setup with only 1 angle range means that the same sprites will be rendered regardless of the angle of the curve. Let's go ahead and add our first sprite to this shape. Under Sprites in the Inspector window, we can add or delete new sprites by clicking the plus and minus buttons underneath. To assign a sprite to one of these properties, we can use the circle on the right. I'm going to use the bridge sprite from the 2D game kit. Our sprite is now assigned to this angle range. I can now demonstrate to you how you can create a shape that uses this sprite. For consistency's sake, I'm going to rename this asset to something more readable. With our SpriteShape profile selected, if you go into the Hierarchy window and right-click, go under 2D Object, and create a SpriteShape, you'll be able to instantly create a shape which uses our selected profile. If you've accidentally created an empty SpriteShape, or you would like to use a different profile, you can go up to the Inspector window, and under SpriteShape you'll be able to select a different profile. The SpriteShape renderer acts similarly to a normal sprite renderer. You can select your desired materials, mask interactions, the sorting layer, and set the order of the sprites. Now the SpriteShape controller is where it gets more interesting. If I click on Edit Spline, you will notice that my scene view has changed, and I can now see 2 nodes on my spline. With these nodes, I can control the shape of the spline. And I can also add more nodes by simply left-clicking anywhere on the shape. You will also notice a set of options for point mode. We are currently in what is called linear mode. Setting a node to linear mode means that 2 straight lines will be formed to each side of the node. The other 2 modes are tangent modes. Selecting one of these modes will form a curve running through the node. Just like so. We can then use the pivot points to control the shape of the curve. It is worth noting that when you're selecting point mode, you're controlling it for a particular node on the spline. In this instance, the outer nodes of our spline are both in linear mode and the middle node is in tangent mode. This node is currently in what is called the mirrored tangent mode. However, there is also the non-mirrored mode. The difference between these is that when you rotate one of the pivot points in non-mirrored mode, the other pivot point stays unaffected. However, if you were to be in mirrored mode, moving one of the pivots affects both. Using a combination of different point modes on the same spline allows you to create any shape you want.
Yeah, how cool was that? So for any of you that are watching on YouTube, if you want to join in the conversation, then please use Unity Connect and we'll answer any of your burning questions.
Right.
So,
Yeah, for sure.
Yes.
So the lady behind this video is Alice. She's part of our evangelist team. And she's actually in Dublin this evening doing another 2D feature talk for one of the user groups. So as well as the online user group, we do have in-person ones too. You can go to the Unity Connect events page and see if there's any near you.
So
right.
I thought that was so interesting to see how environments and platforms can be sculpted and manipulated so quickly. I think that's, you know, how interesting SpriteShape can be. You know, everyone watching saw how quickly Alice put that together and how you know easy it was to freeform these particular platforms. So.
Right, especially using the mirror mode too, and just having the ability to pick it or turn it off. It's astonishing.
Again, it's features that can be used really, really quickly and give you an amazing result. So yeah,
absolutely.
Yeah,
SpriteShape is awesome, but we're not done here. So let's go to part 2.
You might have noticed that the shape we've got right now isn't exactly tiling sprites the way we want it to. We can change that using the sprite editor. I'm only going to go over the sprite editor very briefly in this demo, however there is a very good tutorial on it on Unity's YouTube page. Let's go back to our SpriteShape profile, and from here select our sprite. The inspector window contains all of the import options for this sprite, as well as the sprite editor button. Let's open the sprite editor. I'm going to dock it to the top part of my window for now. Initially, the purpose of the sprite editor was to split documents containing multiple tiles into individual sprite assets. However, it can do a lot more now, and it can also work on single sprites. The sprite editor is a very useful tool when working with SpriteShape. It allows us to determine how our sprites are rendered relative to the spline. There are 2 main options in the sprite editor which will be of particular interest to us when using SpriteShape. The first of these are the border settings. You will notice them here in the bottom sprite window, and you would have also noticed the 4 control points around the sprite. You can either define the borders numerically down here, or you can just simply drag the control points to where you want them to be. Right now I have dragged the left and right control points to separate the middle part of the bridge sprite. When this sprite is used in conjunction with SpriteShape, what this means is that the only part of our sprite which is tiled is the middle section here. The left and right sections are called bookends. They are only rendered at the start and end nodes of our spline. Once you are done with the sprite editor, go to the top right and click Apply. If we now go back into our scene view, you'll be able to instantly see how our shape has changed. You will also notice that our bookend sprites are currently not rendering at our end and start nodes. To fix this, let's go back to our SpriteShape profile, and in the inspector window under control points, you have to enable the checkbox to use sprite borders. And just like that, we've got a new bridge sprite that tiles correctly. Now I want to show you how you can very easily add colliders to your sprite shapes. I think the best way to do this is by extending an existing scene made with SpriteShape. Here I've prepared a simple 2D scene using the assets from the 2D game kit. All of the terrain you see in this scene, as well as some decorations, is made with the help of SpriteShape. Let's bring in the bridge terrain we've created earlier into the scene and add a collider to it. I'm going to select my profile, and with it selected, I can create a new 2D object, SpriteShape. I can now go ahead and edit the bridge to look the way I want it to. All I'm doing here is adding more control points to the spline. The first thing I notice is that the bridge doesn't seem to be affected by the lighting in the scene. I can change this very easily in the SpriteShape renderer just like I would with any regular sprite by assigning a different material to it. Just like this, the bridge is now affected by lighting. So, back to colliders. If I select my shape, and in the inspector window add component, I can use a 2D edge collider to automatically generate a collider for this shape. Right now it's a straight line. However, you will notice that in the SpriteShape controller, I now have an option to update collider. And if I click that and zoom in, you will notice that the collider line, the green one, has adjusted itself to the shape of the sprite. You will also notice that it's not a perfect collider, and I want to edit it manually a little bit. For that, I will untick to update collider, because otherwise it will be updated continuously. And then under the edge collider, I will edit collider and extend it just like this. Let's test the collision by bringing our character closer to this part of the scene. I'm going to select the character and the camera and move them over to another part of the scene. And click play. As you can see, our collider works perfectly. Now, one other thing that SpriteShape supports is having multiple sprites within the same angle range. By adding more than one sprite, you will be able to select which of them gets rendered per each segment of the spline. This way you can add more variety to your environments. I'm going to demonstrate it by using a sprite shape I've prepared earlier, which contains two variations of moss. And I'm going to attach it to this terrain here. Once again, I'll create a new sprite shape, adjust its position, and make it fit the object a little more. Once again, I'll make it affected by light. And now, with the node selected, I can change the sprite index. When I change the sprite index, you can see that the sprite being tiled following my node has changed. If I take a look at my moss shape, you can see I've got two sprites assigned for the same angle range. Using the sprite index, I can switch between these two sprites for each individual node on the spline. This can give you more flexibility in changing the appearance of your environments and adding variety.
So yeah, this uses the 2D or Unity's 2D game kit, which was created by a very talented internal content team.
Yeah.
And you can see Alice put it to amazing use there.
Yep.
Yeah, for sure.
That's available on the asset store.
Yes.
Right. And I really like these assets for like profiler assets, I guess you could call them.
Yeah.
Where you can basically store all of the configurable settings and just have them in one place only.
Yeah,
Yeah.
I agree. So should we have a little look at the last part?
Yeah.
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 Why not?
Now that you're familiar with open-ended shapes and angle ranges, let's take a look at the other types of sprite shape profiles. If we go back to the Asset menu, go to Create, Sprite Shape Profile, you will notice that there are two other sprite shape profile types we've not covered. The empty profile, unlike the strip profile, has no predefined angle ranges, allowing you the freedom to set up your own. And the shape profile comes with 8 predefined angle ranges. For my example, I want to use 4, which is sort of the middle ground. So I will start with an empty SpriteShape profile, and this way I can also show you how you can define your own angle ranges. In the inspector window, you will notice that the angle range circle is empty. I can either click anywhere in the circle or click on Create Range to define a new angle range. Since I want 4, each of them will have to be 90 degrees. I can change the angle range start and end points either numerically or manually. Once I've set up 4 angle ranges, I can now assign sprites to each one of them separately. I'm going to assign 1 sprite to each of the angle ranges and make my shape look like a piece of terrain. The sprites I'm using are part of the tile set from the 2D game kit. While this tile set was intended for use with tile maps, I found it to work quite well with SpriteShape. Now that I've assigned a sprite to each of the angle ranges, I can rotate the gizmo around the circle to preview how my shape would look from different directions. Back in the scene hierarchy, I'm going to add a new sprite shape using our newly created profile. You will notice that this time we automatically generated a close-ended path. However, if at any point you wish to change the type of your shape between close or open-ended, you can do so in the inspector window using the open-ended checkbox. You might notice that there are quite a few things wrong with our shape. First of all, there is no fill texture within our terrain, and second, there are no sprites rendering at the corners of the path. If we go back to our SpriteShape profile, we can fix both of these things quite easily. In order to fill our shape, we have to add a fill texture in the inspector window. We can do so under the fill options right here. I will be using a fill texture from the 2D game kit for this purpose, which I cut out of the tile set. Note that the fill texture currently has to be a singular sprite and cannot be a part of a sprite atlas. Also, for our fill texture to work properly, we need to make sure that in its import properties found in the inspector window here, the wrap mode is set to repeat. If the texture is not imported with the correct wrap mode, the sprite shape will produce artifacting. You can already see how adding a fill texture has changed our shape in the scene. It's looking better. However, the corners are still missing. For this purpose, the SpriteShape profile includes an option to add individual corner sprites to be used in your shapes. If you look in the inspector window, at the very bottom there is a corners section. You can see that it includes 8 corner options for the different locations on the shape. For this example, I will only be using 6. Once again, all of my assets come from the 2D game kit. Once the corner sprites are assigned, I need to tell my shape to use them. For this, we need to go back to our editing mode. And for each node which is a corner, in the SpriteShape controller options, I can set the corner mode to be automatic. Now my shape correctly renders corners. We can add a collider to this shape as well. Earlier, we used an edge collider for an open-ended path. For close-ended paths, we always want to use a polygon collider. If I click Update Collider, my collision box takes the shape of the terrain. However, it's not placed quite where I want it to be. I can adjust the way the collider wraps my shape by changing the offset value in the SpriteShape controller. Just like an edge collider, I can then edit the collider manually as well. Let's test the new collider with our character. And it works. I'm going to open a different version of this scene, where I've added a couple more decorations. Some of these were hand-placed, but you will notice some of them were also made with SpriteShape. For example, these wall and ground decorations, and actually the walls themselves as well. This makes SpriteShape stand out as not just a terrain modeling tool, but also something that can be used to add detail and patterns to the environment. Lastly, I want to give you a glimpse of what can be done with SpriteShape using the scripting API. It is worth noting that SpriteShape is still a preview feature, and as of now, there is no documentation for the API. However, it can be accessed from within your project using the Solution Explorer in Visual Studio. First, I'll quickly demonstrate to you how the script works. In this scene, we have a dropship attached to a node on a SpriteShape. You can see that whenever I move the node, or rotate its tangents, the dropship's position changes. If we look at the script in the component window of the dropship, there are several options available to me. I can change the index of the node it's attached to. I can also tell it to update the object's position while the game is running. And use normals means that whenever that node is not in linear mode, the object will also rotate whenever I move one of the tangents. I can also adjust the object's vertical offset, which adjusts its position relative to the node. Let's quickly take a look at the script. Here we are accessing the spline from our SpriteShape controller, as well as getting the position of the node at the index which we specified. The index also gets adjusted for whenever we add a point before it to the spline. Then, if we choose to use normals, we calculate and perform the rotation of the object based on the tangents of the node with the help of some member functions. Finally, we add our Y offset and perform our position transform, which puts the object on top of the node. This is one of the many things that you can do with the API. If you wanted to, you could use it to make your environment reactive to the gameplay of your project. But even if you're not a programmer, SpriteShape is a great tool that provides a quick way for you to create, decorate, and prototype environments with ease. This concludes my editor demo. I hope you've learned something new today. Let's quickly review what we've covered. I've explained to you the basic principles of working with SpriteShape and navigating the features interface, as well as the creation of auto-generated colliders for your shapes. I've also shown you a little bit of the sprite editor that will come in handy when working with SpriteShape. And finally, we took a look at what is achievable through the scripting API. If you would like to learn more about SpriteShape, here's several links for you. You can find the GitHub repo with basic documentation and sample projects on bit.ly SpriteShape GitHub, or you could access it through the editor itself. The API can be accessed from within the project using Visual Studio Solution Explorer. And finally, please do share all of your wonderful creations and feature feedback on the Unity forums at bit.ly SpriteShape Forum. We can't wait to see what awesome things you come up with.
So, as Alice said, we like to hear from everyone, don't we? So it's going to be amazing to see how everyone uses SpriteShape in their own individual ways, and I can't wait to see a whole load of brand new projects, which will arrive in the next couple of months. So.
Absolutely, and it's not just SpriteShape that we have available too. We've got some great 2D features in preview. So we've got a 2D animation system, which is super cool. Yeah. And then we've also got the SVG importer as well.
Right. And the video is on YouTube, just so everyone knows.
Yes. Yeah.
And that is it. I also like the scripting API for SpriteShape, right? I think it's one of those not features but almost additions and fundamental parts of this feature that really sticks out for me as a coder, as a programmer, so that it's extensible. Yeah.
Because I know Mixstraight asked in the chat as well, it was like, can we change this at runtime? And you totally can. Like, it's super cool.
Right. that was amazing. So we now have a game called Halibut, and so we should perhaps just get started with part 1.
Yes.
We are here with the team from Halibut. And so for those who may not be familiar with your work already, how would you explain it to people?
Well, Halibut is a modern adventure game focused on storytelling and exploration. And the especially unusual thing is that we are actually building all the game assets in a real-world workshop, like in a stop-motion film. So we are building sets and puppets and using photogrammetry, a 3D scanning technique to, like in the Adam movies actually, to digitize all the assets. Then there is of course a lot of reworking, like, doing low poly retopology and so on. And yeah, basically the whole game is hand built. To tell you a little bit about the story, the whole thing plays on a distant planet which is just made out of water. The backstory starts actually in the 70s of our world, and people think the world is going towards its end. It's Cold War and so on. So they construct this gigantic spaceship and leave the Earth to find this to travel to this distant planet, which is 200 years actually of traveling time, since they don't have like fancy warp drives or so. And once they arrive there, they lose contact to Earth, thinking Earth was destroyed. Once they arrive there, they get to see, yes, there is water on this planet, but no land masses, and they crash land on there. And now they are stuck in this world. 50 years pass, and that's the point where we start actually as the player, as Harold, who grew up in this situation basically, and now tries to help Moreau, one of the leading scientists, to find a new way to find a start procedure to leave this planet.
So, looking at the game, one of the first things that really jumps out at you is the visual style, right? It's a very, very unique style. Definitely something I haven't seen before in games. What led you to that initially?
Well, it's a funny story actually. When we had the idea first, we were like 3 friends thinking about, hey, let's make a game because we can tell a story the way we want and the way we want. And none of us could actually do any game-related stuff besides of our love to games. And also, none of us was a 3D artist or a 2D artist. So besides of our love to stop-motion films, actually building stuff felt easier than drawing or doing 3D modeling. So we built the first set for the game. That was about 7 years ago, by the way. And we soon realized that especially character design and modeling puppets was much more difficult. It's actually sad that you can't see my first attempt of making a character. It looks like a zombie, basically. So soon we had another friend of us coming into our team who is a amazing illustrator and artist in general, actually, and you can give him like any kinds of tools and he just does. And even if he was especially specialized in editorial illustration, we just gave him like clay and like tools and told him like, can't you make us a character? And it worked. And yeah, that was the beginning. So it was basically our inability to do anything else than building stuff.
That story of coming out of, not having the resources to do the normal thing, I think leads to a really interesting place. And I feel like that's a really cool thing for beginners to think about, right? Like people who are not experienced making games and feeling like, oh, I don't know Maya, I don't know how to write C#, right? And that's super inspiring.
Another funny thing, by the way, is throughout the development process, of course, we discovered, okay, we will use photogrammetry, we will do the 3D scanning stuff, and we also have 2D art. So right now we actually have like all of it. We have 3D modeling in there, we have 2D.
Additionally to the modeling stuff.
to the physical modeling. So in fact, the like former reason isn't a reason anymore, but obviously.
So photogrammetry is something that kind of we've been talking about and people are starting to become more aware of, and it's something I think that folks don't think of as an indie technique, right? How has that worked for you guys in your process?
Great, actually. It was so funny actually to see your like kind of tutorial document I saw. because we actually had to find out all these things by ourselves, since when we did the first photogrammetry experiments, actually when we built the very first prototype, it was a 2D sprite-based approach with real stop-motion animation, and it felt too static and too rigid, too 90s basically, and we wanted to move away from like both gameplay-wise the classical point-and-click adventure and also visually from, yeah, the static look of having pictures with sprite animation above it, especially because all these physical objects are so detailed and so on.
Yeah.
So we wanted to actually combine the benefits of having the physicality of the objects with all the benefits of 3D engine, dynamic lighting, shadowing, and stuff like that. And also PBR was coming at that time.
Yeah.
And yeah, so we kind of did some research, and I knew there was something like 3D scanning, that it felt so, yeah. We thought
futuristic,
we thought we would need like crazy scanners and so on. And actually, 1 to 3D Catch was, I think, the Autodesk thing, the app, which was the first like moment of, okay, you can take photos and you can create a 3D model. Obviously, the quality wasn't that great.
Yeah, and the cloud took hours.
Yeah,
for calculating
sometimes it
a
just
little
failed.
object. Yeah.
And yeah, then we researched a little bit, came up with photoscan and later capturing reality, which is like super fast. It's crazy actually how they do it. I still don't get it. Yeah, and that was it, and it felt really easy to do because you don't need anything else than a 3D, than a DSLR basically, or a good photo camera. And in our case, a turntable. That was one of the things we found out after a while, that it totally made sense to use a turntable since all the objects we scan are relatively small. I mean, even the sets we can break them up in chunks to scan them. And it has the big advantage of being able to light everything flat, you know. So we use lights from the camera direction. And put the objects on a turntable and take like hundreds of photos of them. And in that way, we don't even have to take special care for like delighting it in a post or so. I was actually really excited to see the delighting tool, but we don't even have a use for that because we kind of went away from that problem in like the beginning. And yeah, it really worked great.
Wow, that's super fascinating. And so, so because you have a uniform light direction from behind the camera, basically, you don't get any shadowing, and then you don't need to delight.
At least we minimize it.
Yeah.
Obviously, you still have kind of like ambient occlusion baked in a little bit and so on, but with a little bit of fine tuning it later and so on. It's really. I mean, these are only details that are easy to get rid of instead of like having really shadows on the objects.
I don't know. As an artist, I find that really inspiring because they're using these new techniques such as like photogrammetry and stuff like that instead of 3D modeling, and that it achieves such an amazing look. And for me as an artist, that's so inspiring, and it's pretty much wanted me to make stuff like that in the future.
I agree, and I also think that it's cool because, for instance, Book of the Dead by Unity's demo team was created with photogrammetry, and it's high quality and tries achieving realism. Whereas this is a little bit more to the artsy side, and it's fun to see what people can create with creativity, basically.
Yeah,
it just shows you how diverse it is, doesn't it?
Yeah.
It shows you how diverse new features can be and the different outcomes you can get from simply, using different techniques more than another. So.
Yeah. And thank you to Onat for joining us in the chat, and I hope I said your name correct. And if you want to know more about photogrammetry, we have a solutions page. So it is, I'll just check the link, unity.com/solutions/photogrammetry. So you can get started straight away.
Yeah, that is awesome.
Sounds exciting.
Yeah. So we have a little bit more about Harold Halibut, and I think we should get started with part 2.
Yes.
Yep, sounds good.
Let's go ahead.
One of the things that we talked about off camera was you've been kind of the evolving rendering of the project. Right?
Yeah.
You were saying that you had in the past using a bunch of post effects from the asset store, but now that you'd evolved in that, maybe we could talk about that a little bit.
Yeah, it was like from the very first beginning of the project, since we aimed for this like filmic, like stop motion like look, it was also important to kind of get that in the engine. So we discovered really fast that there are like a bunch of really great effects plugins in the asset store and tried out a lot of them. I actually maybe bought every single Bloom plugin that was available in the asset store. And there are really, especially Amplify Bloom, for example, and there was the other one. Don't even remember. It has been such a while since we used them. And you know, I was digging through the asset store every now and then and seeing if there is another better one, you know, and that's a nice thing actually, because you don't program it yourself. You see it, and it's like if there is a better one, you aren't even like don't have bad feelings of just replacing it with another one. And it was great, and there are really great effects plugins in the asset store, but since the Unity Post Effects stack came out, there wasn't even the necessity for it anymore, and especially because it's so much faster compared with having this huge stack of effects. And I love the depth of field, by the way. As a filmmaker, you know, it's... And we were actually
it's
looking,
incredible,
just testing for a whole day, looking at different objects and going crazy
zooming
with
in
it.
and out and changing aperture and stuff.
Yeah.
Amazing, yeah.
Yeah, that's really amazing. Maybe if you could put in like some anamorphic depth of field thing in it's soon future, it would be even better.
That's awesome. Yeah. Well, actually, I think that I know no promises, but I know that the
Adam maybe is behind it. I can imagine. Yeah.
Exactly. Adam Myhill, the creative cinema machine, is very interested in creating a workflow that's welcoming to filmmakers.
Yeah.
Right?
Yeah.
So if you have this domain knowledge of filmmaking, lenses, exposure, etc., bringing that through into Unity in a way that it kind of maps one-to-one, which I love. I think is a
and
totally
it's actually
awesome
amazing, you know, because I was totally in love with Cinema Machine, and I also wrote him, and I was like, by the way, it would be so amazing if there was a feature like this, and he was like, yeah, it's in the next version actually, and you can download it in 2 days. Okay, great. Then there was another thing, but what about like this and that? Yeah, we're working on that already. And I was like, okay, I don't need to say anything anymore, you know? Because he also has like some, I think, camera backgrounds and so on, you know? So he exactly knows what I need, basically. So that's really nice for me.
Yeah, totally. And I feel like this is something I would love to see us do more in games in general is... You know, you guys mentioned just bringing existing workflows, existing tool sets that work, and kind of recreating those in the game world. So you mentioned, you know, you have a background in film, working in nonlinear editors, and then being able to kind of bring that knowledge to timeline. How was that kind of played out in the project?
I mean, it has not been such a long time since it came out, so we didn't do a lot with that until now. But we will use it for every single cutscene from now on, actually, and even our reworking the older cutscenes and so on, because it feels so natural, and it's very easy to change things, to add things to there, and even for things like we have an elevator, for example, to be able to really exactly tune it, kind of position the sounds that are like fired, and the animation, and also even lights, or so to be able to control all these things through one asset file, which is also nice. You know, you can even edit it in the play mode, which makes a lot of sense. And actually coming from nonlinear editing, which is already nice, and even for example Final Cut or so, like more recent versions of all these editing tools have the scrubbing, you know, which works great, but you still have at least full HD or 4K footage, and there's a slight latency, and it's just so much fun to scrub through the Unity thing, because there's like a million frames that you can't see any delay, you know. It's really, it feels like the next thing. I actually just want to work on films from now on like this. It would be great.
Well, it's interesting that you mention that, because I feel like that's something that we're starting to see a growing awareness around, right? It's just some of the potential in kind of real time, using real time as a medium for linear storytelling,
Yeah.
right? Which of course we've had games with cutscenes, and that has become a bigger and bigger thing. But it's something that I think we're starting to see more and more, and something. As someone who's also done a little bit of filmmaking, I'm very curious to see what the kids are gonna do.
Yeah.
All the young broke kids, like, what are they gonna do with this? I'm super excited about it.
By the way, we still have like a little more than a year to go, so anything that comes out until then, we will definitely put it in, especially when it comes like to. Also, like the lens things and so on. If there is like lens distortion or so, there was a lens distortion. I think now, and I already tried it out. But for example, if you could kind of mimic different film lenses or so, which I'm sure Adam is working. Thank you, Adam. By the way.
Totally.
So one of the really cool things at which they were talking about, and I also noticed in the chat, they're using the post-processing stack, and me and Liz are obsessed with the post-processing stack.
Yeah.
I don't know, for some reason it just adds that final layer and just completes that whole project and product. It's incredibly useful for if anyone's not used the post-processing stack. I think we highly advise you to have a go, because there are so many new features, especially with the version 2. So.
Yeah, and it's just on the package manager, so you can download and get post-processing.
Right. And besides the post-processing, they also talked about the filmmaking features, and that's true because they really have been shining lately on Unity as like the timeline feature, the Cinemachine, and so many other stuff coming out. And we also have something about that, right?
Yeah. So timeline, Cinemachine, post-processing, all of our like filmic tools. I know I'm like the solutions page evangelist, but we have a solutions page for that. So if you go to unity3d.com/solutions/film, there's everything that you need to know about Cinemachine, timeline, post-processing, the animation system, the digital content creation, import and exporter, and also the recorder as well. So there's everything.
That's very cool. It's almost like a collection then.
It is. It's beautiful.
Nice. So let's go ahead and check out Harold the Halibut Part 3.
Another thing that we talked about a little bit was that you guys are thinking about switching to the HD scriptable render pipeline. It's a big move. I'm interested to hear how you're thinking about it.
Yeah, I mean, we are still so early in the development. I mean, even though like the pipeline is set, we have built a lot of things in the physical world. We have even
digitized them,
digitized them, and so on. We wanted to kind of like finish like all the edges of the engine before like putting everything in there, besides of like, of course, putting sets in and being happy just seeing them in the engine. And so that means now would still be a good time to do this, instead of like, we wouldn't do this obviously if we were so much into everything, and we would need so much time to kind of tweak everything again,
update all the materials and stuff
like that. And we have like all the Substance Painter projects still, so we can just export the new textures we really need, and that's also something. So we looked into all the things that we need to additionally, for example, and that needed to be changed, and just realized that it's not as much as we had thought. So in our case, and because we are mostly relying to Unity's own like tools now, graphics-wise, be it post effects or shaders, that's also one big point. We don't have to like kind of rewrite shaders, and actually we get some new things that we really needed, like the transparency things, which will, as I understood at least, work correctly now, and we always had problems with transparency sorting. And besides of that, it's because of like all the scanned materials and things, what was very important, let me just think, one asset actually we rely heavily on is amplified texture, which is the texture streaming, because we have like 8K textures for almost every single object. Some of them are only 4K. So you can imagine it wouldn't work with just putting the textures. We would have to scale them down and lose quality, and
you can't see the fingerprints in the models if you scale down the textures that much. So
yeah,
we rely on that.
Yeah. And that's basically kind of like an implementation of its software's mega textures, and that will be one thing we will still rely on. And but we are also talking with these guys, and they are also porting it to the HD pipeline, so that's important. And besides of that, our especially performance-wise, for example, our game is actually quite low. We have everything is very low poly, even if it looks so high def because of the textures.
Yeah.
And what like kind of is most performance-wise is most like
post-processing
expensive.
Stuff.
Yeah, even the post-processing is quite fast nowadays. Yeah. Like what's like costing us the most is like the sheer amount of lights and shadows we use, and through like the tile lighting and the light culling and so on. We even in like our very first tests with like the beta, it was already so much faster than what we are using now, and like in the deferred pipeline. And in the meantime, delivers an even better quality. So it was a no-brainer actually, and pushes it a little more to that that feeling of it almost looks like the real thing right now. And with that, I think it's even in the first test, it was like you kind of deleted the blur layer from it. It was everything was a little bit crispier and nicer, and the subsurface guttering is especially something that really adds to the.
Yeah, and I think the new Disney BRDF.
Yeah.
It's very nice. Yeah.
Yeah, I have one more thing. It's actually the most important thing. I hated the light intensity to 1 slider, because you know,
one to what? What means 1?
Yes, it was so difficult because we even made lists with like, you know, we actually had the possibility to have the real objects and put lights in there, and kind of looked at how it looks, tried to recreate that in the engine, looked at the light intensities, wrote them down, and kind of created a list for us to work using kind of real, you know, values compared with the Unity's 0 to 1 or whatever, or
more than 1.
More than 1 values, yeah. And it was super difficult to, so you couldn't just do the basic setup by saying, okay, normal light bulb would have this value, and we just put it in there and it works. But you had to experiment, you had to try things out, and especially when you then, through post effects, for example, can even make changes in the general exposure itself and other things that have an influence on the overall light amount. You have absolutely no idea where you are right now compared with the reality, and that's something that's really amazing with the HD pipeline, that you have like real world values for everything, and everything behaves like...
Physical properties are reliable.
Yeah. Yeah, the real reliability, that's the thing especially,
As we start to move into these kind of photogrammetry workflows, and also as the kind of line between film and real time starts to blur, it makes sense, right? If you're a filmmaker, you want to put up a light meter and measure, you know? And
absolutely.
That's a skill set and a craft that people have, you know? So the fact that you would have to go and do some weird conversion to some arbitrary values in a game engine, it's very interesting. I feel like we're in a moment where we're having this kind of cross-disciplinary moment where these disciplines are coming together in the real-time engine, and a lot of stuff that we always just did in games because, you know, 0 to 1, slide it down. It's like, it's not quite going to make it anymore. I mean, this makes me think about a kind of a stylistic or aesthetic question, like, so what does realism mean for your game, right? Like, you have this thing, you're trying to reproduce these not real models and environments, but you're trying to reproduce very accurately. It's a very interesting question of realism.
It actually is, yes. And that's, I mean, what I tried to describe also before is one important point that we use as a incredibly helpful tool is actually to be able to compare the real things with the digital things, which really helps us to nail the look, you know. So even when we are tweaking texture values or material values, or these guys, by the way, Gab also has another company, and they invented this crazy material scanner.
We built a material scanner to capture real-world surfaces and getting PBR textures out of it. So we can match these textures with the real objects. We have a perfect showcase for these PBR textures, and it fits perfectly.
Yeah, and also, so we have the kind of like the perfectly measured values from their textures, and we have the real world objects to compare with our eyes and so on, so we can kind of tweak everything so it looks closest to the real things we build. And but what you said is also interesting. It's not like real in terms of photorealistic, but which, by the way, also helps because it's not the uncanny valley effect you would have. So you can get away with a lot of things because it is still abstract. And of course, we don't want to just like stay in the, it should be like this because it's real. But we make also use of things like a little bit over-exaggerated, like volumetric lights and so on, because it adds to the atmosphere. So we have the freedom to use, these more abstract and digital things as we need to add to what we in the first pass try to recreate as perfectly as possible, because it gives us the kind of like the baseline to know, okay, this is how it should be, and from there on it's like adding like effects,
Super cool. Super cool. So I think for people who maybe are not yet in games or not yet doing real-time artwork, given that you kind of came in from film, what would you say to filmmakers who are maybe looking at this and thinking, oh, maybe I'm interested?
You shouldn't wait too long to learn Unity. Actually, it's in between. I even had some jobs, some motion graphics jobs, and there were sometimes you have like was heißt Kunden nochmal? Customers. So sometimes you have customers who are like, yeah, we need this and that, and you have 2 weeks of time actually, and obviously you could do these things with After Effects. You couldn't even do them in a classical like 3D environment because the rendering alone would take too long.
Yeah.
And I've made some things with Unity now which you can blow up to 4K and just render. I mean, saving the JPEGs takes longer than actually rendering it, and that's amazing. And the extendability of the engine to fit like exactly your needs is really an amazing thing. And it also, and this would be only the thing that would be useful for filmmakers, for example, but it also enables creators in general to kind of leave the boundaries of the medium, because that was, for example, we wouldn't have done Harold Halibut as a film because the story we have written is a story that works as a game in an interactive environment, and there is not like this one medium where you can do like all the things, but like several different media which are more suitable for the one or the other story or project. And to have a tool like Unity enables, actually breaks with these boundaries that you have between like film or games or even other like installations. For example, you can do. We did some projects with Uniduino also in the asset store. I don't know if it's still there. You could like connect Arduino to Unity and do stuff with like you have so many possibilities, and that's something amazing to have. And even if you know only a little part of it's actually great to be able to only know a little glimpse of it, even after you're working for years with that, because you can always use it and do more things with it. And yeah, it's super exciting actually. It's like a gigantic tool set that never ends.
That's awesome. I think that's a great note to end on. A giant tool set that never ends. Amazing. I love that. So if people want to find out more about you guys and about your project, where should they go to connect with you?
Yeah, they can visit our site. It's www.haroldhalibut.com. I guess you are also like putting it somewhere.
Hopefully.
And Yeah, we're on Twitter, on Facebook. It's always the same, actually, and on Instagram, which is interesting because we have, like, especially on Instagram, we have the kind of making of things, like all the hand-built assets. There, it's divided by a underscore. Yeah. It's Harold Halibut. Besides of that, it's always the name. But I guess this was, by the way, one of the reasons for this name. You can just Google it, you know. So we wanted to find a name that when you put it into Google, you won't find anything else but this game, which kind of worked out.
I mean, that's actually a super good tip. People always, like, I see people, like, struggling over names.
The cave or the room or so, you know, something like that. No one finds me.
No. It's a really good tip for people just in terms of, like, basic, you know, being able to be discovered is really a great tip. And platforms, where's it going to release?
It's PC, actually all the platforms almost. It's
starting on PC.
Starting on PC and on the consoles, Xbox, PlayStation, and Switch. And yeah.
Awesome. Okay, well, thank you guys so much for joining us. Super interesting.
Thank you.
Love to hear more soon.
Thank you.
See, I find that so cool because they're blowing the bridges between films and games, you know? They're talking about breaking down those boundaries and they're completely doing that. And again, I'm going to reiterate, I find that really inspiring, just the fact that all these skills that they're learning in film can be, you know, used better or even better in games. So, yeah.
It's an exciting time.
It really is.
Super transferable.
Yeah.
Thanks again to Onat for joining us in the chat. It's super kind of you and super great. And again, just to like recap, if you want to find out more, you can go to howardhalibut.com.
Yes. So our next one is HDRP, the high definition render pipeline. Hopefully everyone learned some things. It's a very brief overview, but yeah, I hope you enjoy. Let's just go to part one.
Yeah.
Hi. My name's Kieran Colner and I'm an artist evangelist. In this demo, I'm going to talk about asset implementation and give you a feature overview of the high definition render pipeline. I'm going to introduce what a pipeline is, provide a feature overview, show how to effectively implement assets, and then take these new features and put them to good use by creating a realistic looking glass material. I remember when I was first told about the new pipelines, my first initial questions were, what are they and what do they do? So I'm going to keep things nice and simple. What is a render pipeline? Well, a render pipeline in general terms is the number of techniques used to get an object onto screen, and it roughly encompasses culling, rendering objects, and post-processing. And of course, these can be subdivided into their own different categories. In 2018.1, we introduced a system called the Scriptable Render Pipeline, and as the name implies, it's a set of C# APIs that allow you to script your rendering pipeline. For the majority of use cases, we provide two ready-made pipelines called the Lightweight and the High Definition. These pipelines allow you to customize what you require for the graphics in Unity. The pipelines can be used without the requirement of coding knowledge, which, for an artist like me, is great. But in contrast, with coding knowledge, that's when they become fully scriptable and fully customizable. Each pipeline was created for a different purpose. The lightweight render pipeline is what we consider our general purpose pipeline, and it covers PCs, all consoles, and mobile. Whereas we have the high definition render pipeline, which is designed to be used for consoles and PCs, devices that can handle intense graphical processing. With the introduction of the high definition render pipeline, it prioritizes high fidelity visuals. Have any of you seen our Book of the Dead demonstration? Well, this demonstrates the capabilities of this feature. It all runs real time and can be altered and changed at the click of a mouse. At GDC 2018 in San Francisco, Natalia dove into what was possible with the high definition render pipeline by demonstrating the fundamental components, features, and techniques used to achieve the most realistic looking experience Unity has ever created. The high definition render pipeline breaks down the boundaries of graphics within the engine. Now more than ever, artists, programmers, and fundamentally anyone that wants to have a go can create gorgeous looking projects with the right know-how. If you want to play Book of the Dead or download it for yourself, you can either follow a link I'm going to provide for afterwards, or simply type it in the asset store within the engine. And explore. It's incredible to see how the high definition render pipeline has been used to its max potential. And it really pays off. It's a beautiful experience. I, for one, love the HD render pipeline. As an artist, it puts the power back into my hands again. Admittedly, it did take me a while to get used to it, But once I understood what the new features are, I was creating things that I never thought possible. Did you know it can handle more lights and more materials than the legacy pipeline? It can handle 24 lights per pixel, compared to the lightweight or the built-in pipeline, which can handle 8, which is still quite a lot. So here are some of the many features within the high-definition render pipeline. Some of the most interesting stuff is in the shader library and the materials. So we have subsurface scattering, anisotropic, iridescent, clear coat, tessellation, transparency, and decals. And a lot of this stuff I do cover in my demo. We have the procedural sky, which allows us to customize the sky and its parameters. We have the HDRI sky, which constructs an environment map on an image set within a component. It uses a cube map, and for any of you that don't know what a cube map is, it's a collection of 6 textures that represent a 360 view of the environment. These 6 faces form a cube, each face representing a direction of world space: forward, back, left, right, up, and down. We have light entities, specifically the real-time line and area lights. I use a few of them in my demo, and they're really quite cool. And then finally, we have the debugging and rendering. So the high-definition render pipeline is a hybrid of deferred and forward cluster rendering. And a really cool thing is the debugging window, and I'm not going to spoil it, I'm going to show that in my demo. So I just wanted to draw a comparison between the default material inspectors in both the legacy and the high-definition render pipeline. There are loads of new preferences that have been added. And here we have an entire section about surface options. We have surface type and material type, which I'll dive into in my demo. You can determine whether the material will work with decals by enabling it. You can also determine whether material is double-sided. We have displacement mode. We have vertex animation, in this case the form of wind. We have a mask map, which is a combination of metallic, ambient occlusion, detail, and smoothness maps. We have the coat mask, which simulates a glossy clear coat effect. And then finally we have the detail map, which is used to add micro detail to a material. So the high definition render pipeline general workflow is that it should ideally be picked at the start of a project, represented here at the design text select stage. But you can upgrade your project by going into the new package manager that was introduced earlier this year, represented at the prototype stage. But beware, once you've upgraded your projects, there's no real going back. Just as a heads up. If you wanted to upgrade your entire project midway through development, it could require a lot of work, but it's completely possible. When you launch Unity 2018.2, you would pick one of them, and then the world's your oyster. But what if you wanted to put assets into the pipeline that were created before the introduction of the pipelines? In other words, created with the intention of using the legacy pipeline, such as asset store assets. Well, this requires upgrading, and that's one of the things I'm going to show today. The asset upgrading follows exactly the same workflow for whether you implement the render pipeline through both Unity Hub or Package Manager. So here we have Unity Hub. Unity Hub is a separate application which was introduced earlier this year. This application allows me to track and manage my projects that I've created on this device, as well as showing me what version I'm using. No longer shall I be that person that would click the Windows button and hope that the right version of Unity would load. And for a user who has to manage a whole variety of projects, this is great. So I'm going to create a new project in Unity 2018.2. I'm going to name it something relevant, and under Template on the right hand side, I'm going to click HD Render Pipeline, and then I'm going to click Create. So yeah, I kind of wanted to give an introduction to the HD Render Pipeline because it's such a new feature. Because it's still in preview, there's not really a great deal of documentation regarding the high definition render pipeline at this point. So I thought it was interesting, and I thought it would be, you know, informative to give everyone kind of a breakdown of what the high definition render pipeline does before going into the demo, really. Yeah. Like I said, to reiterate, it's still in preview, but everyone has access to it, and I fully encourage everyone to have a go, as you'll see in the next clip. So should we go to part 2?
Sure.
Shall us?
Yeah. So, the project's opened, and here we have a scene that I've created, and it's an amalgamation of both asset store assets and assets I've created, such as this lovely custom Unity toaster. And this scene pretty much encompasses a lot of the new features found within the HD render pipeline. So, as I mentioned earlier, what if we wanted to upgrade the project? Well, we would do this through Package Manager. And the way that we access Package Manager is we go up to Window and Package Manager. And it presents us with a window. So we have two tabs. We have In Project and we have All. The In Project shows us everything that's in our project currently. If we were to go to the All tab, I can now start to see everything that I could add to my project. So here we have the HD render pipeline. I've already got it installed, but you would install it this way. So how do I take my recently installed pipeline and implement it? Well, I want to go to my project's graphical settings. So the way I do that is I go up to Edit, Project Settings, Graphics. So within the Inspector module, I can see we have an option called the Scriptable Render Pipeline Settings. And once you've downloaded your pipeline, you would click on the button on the far right, and you would assign the HD render pipeline asset. So now let's dive into some of the features. Lighting in the high definition render pipeline has moved to using a system called physical light units. Now, physical light units mean that the units are based off real world measurable values, similar to what you would see when browsing or shopping for light bulbs. Light emitters such as directional light use a luminosity value called lux, while light emitters such as point lights, line lights, or area lights use lumens. This was introduced because the directional light in most cases was the most powerful light emitter in the scene. When a lux value starts to decrease, it becomes less accurate, which is why when using smaller light emitters, like the line light, it's generally better to use lumens, as the light value is more accurate to what you would find in the real world for such small values. So the line light maintains a seamless constant light output from a custom line length. I can determine the line length using this value under Shape. As I decrease it, you can see that the line shrinks, and as I increase it, the line expands. So these lights are commonly used for animated films, and they achieve realistic looking lighting, and I find it seems to add some kind of like filmic quality to your scene. And that's why I like using line lights. Another cool thing is we have a temperature gauge, and I can start to determine the light outputted through temperature. So I can decrease it from left to right. As it gets red, that means the light's getting cooler. And as it becomes more blue, the light's getting hotter. Of course, like I mentioned earlier, we have an intensity, and this is under lumens, and it's currently set to 126. Through research, I kind of figured out the average for most lights of this caliber are between 175 and 500 lumens. For the context of this scene, 126 seems to work best. So here we have the planar reflection probe, and for any of you that have used the standard reflection probe, this will seem very familiar to you. The planar reflection probe is used to generate realistic looking reflections on a surface, in this case, a kitchen worktop. Within the inspector, I have a whole load of influence settings. We have a box size, and this will determine the influence bound by a box, box offset, influence fades, influence settings so I can determine the weight or the multiplier. Just to show, if I click this little modify base shape button, I can start to determine the bounding box. So as I decrease it, the reflections disappear, and as I increase it, the reflections come back, creating nice reflections on the surface. We have a new cool feature called the volume settings, and what the volume settings do is they allow you to visually alter your environment preferences, adjusting elements such as your visual environment, procedural sky, HD shadow settings, and even enables you to create custom profiles and switch between them. If I were to zoom in on the inspector, we have our HD shadow settings, and we have this value called max distance, and this will determine the quality of the shadows depending on how far away you are from those particular shadows. We have your visual environment, and we can start to determine the sky type. We have two options, HDRI sky, which I'm currently using, or procedural sky. So this volume is managed by creating a game object and adding a corresponding component, just like you would when creating a volume for the post-processing stack version 2. In the high definition render pipeline, there will be one present in your hierarchy by default. And of course, we have post-processing. I've done quite a lot of post-processing on this, included stuff like color grading, bloom, vignettes, ambient occlusion, and I've added a bit of auto exposure as well. The high definition render pipeline has a really cool new feature, and this is the new debugging window. And this allows us to view our scene with unique preset options. Let me show you. So to access my debugging window, I want to go up to Window, General, and Render Pipeline Debug. So the debugging window allows me to pick apart different layers of my scene and see it for its segregated parts. This is incredibly useful as I can see where particular components are influencing my scene. These debugging tools further empower artists to investigate any graphical problems within their content. You can use this feature to figure out if you have artifacts within a scene, such as anomalies of why particular sections are looking too dark, or a texture isn't performing as expected. We have material. This allows me to segregate a particular material type and its components within my scene and show it to me within my viewport display. So dropping down, I want to go to lit because all of my materials within my project are being influenced by light. And you can see it gives me quite an expansive list of different materials, ranging from opacity all the way down to transmittance masks. Although a lot of these would be useful for users and developers who use quite complicated materials, again, we wanted to make sure that this feature was accessible to both novice and expert users, but we do have some rather familiar material names, such as base color, specular occlusion, normal, smoothness, ambient occlusion. If I pick normal, my viewport now changes according to normal maps applied to my materials within my scene. So of course we can see the tiles within the back, we have our stores which have a noise normal map applied to them, and we have our wall which you can't really see but it has a noise normal map applied. And the same would be said for base color and ambient occlusion. So let's go to base color. And I can see my scene for its base color rather than it being influenced by light. I can see all the textures quite clearly. And the same could be said for ambient occlusion as well. And I can see all of the ambient occlusion maps applied to my scene. Moving down, we have lighting. And this is where I think the feature comes into its own. So watch this. So at first this can look pretty daunting. I remember feeling exactly the same way. So one of the first things I'm going to do is override my albedos and normal colors, and you'll see why I do this later. So if I go to my debugging modes, I'm only really going to focus on the top two options, diffuse lighting and specular lighting. Like I mentioned earlier, I can now see how my light is influencing my scene. With all the materials and lighting combined, I find it quite hard to interpret and understand how many reflections are actually occurring within my scene. Even I struggle and simply turn up the specular material and don't really think about what it's doing to my scene. Well, this allows me to check according to my preferences. I think it's a really cool feature. The amazing thing about the scriptable render pipeline architecture is that you can make your own debugging effects. You can start to extend certain preferences and fuse elements together to create custom debugging tools which are tailored to your requirements. Similar to what was shown at the GDC talk I mentioned earlier, in which the developers created custom sky occlusion modes, which showed how the directional light reacted with the rural environment. The thing that blew my mind when I was investigating this is that the modes can be accessed once the project is running. You can see these modes on platforms such as Xbox or even PlayStation. So now let's grab an asset from the asset store and put it within my scene. So this pan doesn't look quite right, and this is Unity telling me that the material is not compatible with the HD render pipeline, and the material needs upgrading in order to access the whole variety of new material inspector features. I can see on the right hand side under its shader it says standard, so I know this needs upgrading. So from 2018.1, Unity has a built-in material conversion function to convert any Unity built-in standard or unlit material to a high-definition render pipeline version. But for other types of material, such as custom shaders, they simply won't work. It's something to keep in mind. So let's access the conversion tool. If we go to Edit, Render Pipeline, and I'm going to focus on the top two options. So the top option converts all materials in a scene to be compatible with the high-definition render pipeline. The second does the same thing, but allows me to choose what materials I want to convert. So I'm going to click the top option, and Unity will provide me with a tip saying to back up my project. And I'm going to click Proceed. And there we go. Easy as that. The materials have now been converted to the high definition render pipeline material, and I can see that within my inspector. If I go down to shader, I can see that it set it to HD render pipeline lit. And if I were to go under the render pipeline, I have a whole list of different options I can choose, ranging from decals to unlit. And of course, exactly the same as the legacy version, if I were to select unlit, it's now created a material that will not be influenced by light.
So yeah, like I said, that was a very brief feature overview. I wanted to make it really, really clear because I'm an artist, I'm not a programmer, and I wanted to show HDRP from an artist's perspective. So showing stuff like the debugging mode. I know a lot of you want to know about that debugging window. I wanted to skim over it very, very quickly because it's quite a complex feature, but it's incredibly, useful, especially in that GDC demo during the Book of the Dead. They created their own custom modes for that debugging mode, or for the debugging window, to see kind of lighting within their scene specific to what they wanted. I personally don't know how to do that because I'm no programmer, but I can see how useful that can be to create your own custom modes. Yeah, playing our Reflection Probe, we were fanboying it over earlier. It's one of those things which is just going to be so incredibly useful, and it's you can start to change all the different influences and all the different values and come up with something completely unique.
Yeah.
So I think it's really great that you've taken this stance from an artist's point of view and broken down the barriers of HDRP. Like, if you say high definition, then you automatically think, geez, this is some complex stuff, I'd better step back.
Yeah.
And like Matt said in the chat, like, HDRP is not easy mode,
It's
but
not.
actually it is accessible.
It's fully accessible, and that's why I think Unity are making the push to put the power back into the artist's hands again, like I mentioned. It's all about giving the artists the tools and then giving the programmers the the ability to extend these tools according to what they want. Right. And I think that's why HDRP and that specific API is just is an incredible new feature. And just to reiterate, it is still in preview. I just wanted to mention that. So
if you are a programmer and you're wanting to maybe extend one of the scriptable render pipelines or create your own, you can jump on the GitHub. We do recommend starting with lightweight.
Yeah, think of it like a building block. So HDRP has all these different implementations that Unity have already added, where lightweight allows you to build upon it. Yeah. That's not to say that you can't build upon HDRP. It's just I would feel that you would need a little bit more coding knowledge compared to if you want to start doing coding for graphics. I would recommend, and so would all of us here, to start with lightweight.
Yeah,
definitely.
For sure.
So yeah, should we go to the final part?
Yeah.
Perfect. Let's go ahead.
So before the render pipeline, creating glass was quite a task. There was no real way of creating realistic looking glass, which didn't require extensive research and programming, and I would always run to the asset store. Now with the new features within the material settings, I can create glass that not only looks great, but refracts to my own preferences. Let me show you. So here we have a sphere, and I put this in the scene because this best demonstrates the capabilities of this material. So, speaking of which, I'm going to create this material by going to Create, and then Material, and I'm going to name it something relevant. And then I'm going to apply it to the sphere. So now we have access to the brand new Material Inspector tab. And if I were to zoom in our surface options, we have a thing called Surface Type. And as I mentioned earlier, we have two options, Opaque and Transparent. Opaque simulates a completely solid material with no light penetration. In contrast, Transparent is an alpha blend and it simulates a translucent surface. And then I'm going to go down to my material types. So this is what I would consider one of the best new features within the Material Inspector, as these options create new behaviors that allow me to create even more realistic looking materials, each option providing additional parameters within the inspector once activated. So, for any of you that don't know, subsurface scattering works by simulating how light interacts and penetrates translucent objects like plants, and is also used in different verticals of ways of simulating skin. Have you ever shined a light through the tip of your finger? This light appears to change colour as it interacts with the different layers of tissue, and subsurface scattering is amazing for that because it's really good at simulating skin. So light gets absorbed by the material, scatters, and then exits out a different location, and this is how it simulates that layered look. This option allows us to create anisotropic materials. Think of brushed aluminium. So instead of creating really nice clean reflections, it's going to jumble up those reflections and defer them and create reflections that are reflecting in all kinds of different angles. We have iridescence. It creates kind of a rainbow sheen around the border of the material and gives it quite a nice look. So I'm going to go with iridescence. So now we have our input, and this will be really familiar as it was in the previous iteration of the material editor. So I want to make my glass quite dirty. So I'm going to go for a light-ish green, and you can see that my material starts to change color. One of the most important things to remember is the alpha. So the alpha is determined from a value of 0 to 255, 255 being completely opaque, and 0 being transparent. And as I start to decrease the value, you can see on the left, my material starts to become transparent. So I've set mine to around about 30. An important thing to remember, now that I've set the alpha to 30, even with my surface type set to transparent, if I were to set it back to opaque, it still is opaque because this determines the surface. So now for the really cool bit, our transparency inputs. So the transparency inputs is where we can start to determine parameters that will affect the overall transparent effect. The transparency inputs will only become available once the surface type is set to transparent. So here we have our refraction model, and we have two options, plane and sphere. For filled objects, you would use the sphere model with a refraction thickness approximating the size of the object the material is placed on. In other words, the thickness would be determined based on how big the object is you're applying the material to. And then you have plane, and plane's really good for empty objects. And with this, you would use plane mode with a small refraction thickness. So for this demo, I'm going to select sphere. So here we have our SS ray model. We have two options again, proxy and what I would call high Z. And what proxy does is it approximates the scene by a simple shape, performs a ray cast against that shape, and then computes the deviated light. And now we can start to mess with our index of refraction. So the index of refraction ranges on a scale of 1 to 2.5. And adjusting the parameter will provide a different refraction intensity. So by default, the value is set to 1, and this generates no refraction. As I start to increase the slider from 1 to 2.5, I can start to see that it starts to refract the environment. And as I look around, the entire environment is refracted, and we can also see the iridescence on the top of the orb. If I were to turn off iridescence, that rainbow sheen would disappear. So let's change that back to iridescence. So our refraction thickness, mine is currently set to 1, and that's what I'm going to leave it at. But you do have your refraction thickness maps and your refraction thickness multiplier. So that, in essence, is a way of creating realistic looking glass material that refracts to my own preferences. And one of the really cool things I like to do, which is just part of my general workflow, is apply a normal map to the surface of my glass. And the way I apply a normal map is I go to the normal map, I click, and I'm going to search for scratches. And once that's applied, I can see that the surface of my material has now started to use the normal map and create a rough surface. And I can increase or decrease the slider to increase the intensity. So I'm going to set mine at about 0.2. And you can still add more detail using the new options provided in the material inspector. So now, let's apply this to our glass behind. I'm going to assign the material to the glass, and there we go. But there's something not quite right about it. I'm not seeing this top rim. And this is because I haven't set the material to double-sided. So Unity is only generating the face of the material that is facing me. So the way I fix this is I go into my material, and I select double-sided. And now that that's ticked, I can now see the outer rim of the glass. So this is how powerful this particular feature is. So if any of you are interested in reading more about the high definition render pipeline, then please check out Sebastian's blog on visual quality. It explains everything I've pretty much mentioned, but it also goes into detail about lighting and how important lighting is within a scene. I've also linked the GDC talk, which announces the Book of the Dead and shows how the Book of the Dead is used to its max potential. So we learn what a pipeline is, how to implement and upgrade assets, and then finally how to take the new features, put them to good use, create a realistic looking glass material that can be used throughout any project. So thank you so much for listening, and please do follow me on Twitter. Here's my Twitter handle. And download the HD render pipeline for yourself. Have a play around. The reason why I put this handle here is because I want you to let me know how it goes. I want to hear about your experiences. Thank you so much for listening.
So yeah, I hope you guys enjoyed that. I kind of enjoyed watching it, actually. I kind of feel a little proud. Thank you. So yeah, I think the really important thing is the HDRP at this current point, like please going to reiterate, it's still in preview. And at this point, I saw a couple of you mention in the chat, at this point, it's not really made for games. A lot of what we're diving into at the moment is like pre-visualizations for like architecture and stuff like that. Not to say that it can't be used for games. It's just HDRP is so new. There's not really been, there's not really been a chance for anyone to start creating games yet. But yeah, so.
Howard Halibut uses HDRP, doesn't it?
Yeah, they just moved into HDRP.
So that's exciting.
Yeah,
So
pretty
it's like
recently.
Kieran says, it's super new. So.
Yeah, it's super new, and I wanted to show everything that I ran into. So when I first done HDRP, all of everything that I was showing you, I ran into, and I wanted to make sure that if I had ran into it, then maybe other people would. Stuff like upgrading assets. So I literally dragged an asset store asset into my project and it came off like a vivid pink. And this is not because HDRP is broken. This is because Unity is telling me, oh, you need to upgrade it in order to access all of the new material inspector options. And a lot of you are talking about subsurface scattering. I am a fanboy of subsurface scattering and I've only recently got into it. If you follow me on Twitter, I'll give you my Twitter handle afterwards. I done a Unity tip this week about the very basics of subsurface scattering. So if you were to click the subsurface scattering options, Unity provides you 15 different diffuse profiles, 2 preset ones. So you have a preset skin and you have a preset foliage, and the skin simulates skin, and the foliage does a really good job of creating like a material that light is penetrating through, and you can see it on the double-sided material. So yeah, please check out my Unity tip. It's about a minute long, and it pretty much shows you how to use all the different parameters within the fusion profiles. And yeah, I'm glad that everyone I hope that everyone learned something, especially because there's not really a lot of documentation about HDRP at the moment. That's not to say there won't be in the future. It's because it's such a new thing. Everyone wants to get these features right. Yeah, I just can't wait to see what people come up with. I've seen quite a lot already, but yeah, I literally cannot wait to see what everyone comes up with in the near future, really.
Yeah, it's exciting times.
Yeah, it really is.
It's good fun.
It really is.
Yeah.
So,
and speaking of learning new stuff, I know that I learned something new at least from this part. And I mean, when you in the first part at least, when you compare the material inspectors from the legacy one to HDRP, I understood well, there's a big difference, actually.
I think it was important to draw the comparison because then people can understand what new features are new and what are not.
Right.
Stuff like the inputs, like a lot of that base color input is exactly the same, but there are a lot of factors that can determine the output of that input, such as like the surface type and stuff like that. And I thought it was important to highlight some problems that people might run into where they're not achieving the look that they want, and that can literally be due to changing an option within that surface material material inspector. So yeah, HDRP is such a complex topic, and it's incredibly hard to cover HDRP all in one talk. So I've tried to narrow it down to the important things that I thought were really, really cool. And if any of you want to investigate any more things, then please do let me know, and please ask any of us on Twitter, and we can relay you onto the right person who can give you the information that you need. So,
yes, definitely.
So, I can't believe we're at the end.
I know.
So we've done SpriteShapes, we spoke to Howard Halibut, we spoke to Grammetry, Cinemachine Timeline, and all the way through to HDRP.
Yeah, and speaking of which, there's a blog post coming out actually. So I've been working on the blog post for the past month, and that's scheduled for a mid-September release. And that pretty much goes over everything that I covered in my demo in kind of a text format. But it will be part of a blog post series where I dive into different features that I didn't cover within the talk that I presented today. So yeah, keep an eye out for that on the blog posts, and I hope to have a discussion with any of you regarding HDRP. So yeah.
So thank you all for tuning in and joining us and participating in the chat. Thank you, Mr. Shell, for being the chat master.
Yes, thank you.
Yeah.
So yeah, I am Liz McCurry.
Yeah, and I'm Sam. Thank you so much for joining, everyone.
Yes, and I'm Kieran. I'm the new art evangelist. So yeah, I'm pretty sure we're going to be here for the next couple of minutes answering any questions that you that any of you have. We'll try our best to answer them. And yeah, I'm looking forward to seeing what everyone comes up with.
Yeah, me too. Thank you very much.
Thank you.
Thank you.
Bye.